we are continuing with Chapter 10, Section 1, dealing with circles and circumference. Now, sometimes you're asked to find the approximate circumference. Sometimes you're asked to find the exact. So, whenever you're asked to find the exact circumference, okay, just know that you're going to need to be in terms of pi. And in terms of pi means your answer will just have a pi symbol right next to it. Now, what's our formula for circumference? There's two formulas that you should be able to use. What's one of the formulas for circumference? What do you have to do with the diameter? You got to take pi and multiply it to the diameter, right? Or it's equal to 2 times pi times the radius, right? Because the diameter is equal to 2 times the radius. That's D is always equal to 2 times r. So another way of looking at it, hey, there's the 2, right? There's the r. D is equal to 2r. Okay, so let's just go ahead and highlight the diameter right now. Or not highlight it, but label it. Bigger line. Okay. So our diameter of this circle is the chord that passes through the center. So if we knew the length of this diameter, all we have to do is just multiply by pi, and we would be done. Now it looks like we have a certain type of triangle right here. That's a 60-degree angle right here. What do you think this angle is here? 80. 30, 60, 80. I think that's 90, man. I don't think that's 80. Let's just check. All right, let's just take this protractor right here. All right, and put it right there, and let's rotate it, rotate it, rotate it. Let's see if it. Yeah, that's a 30, 60, 90 right there. That's a thing. It's a 30, 60, 80. That wouldn't make a triangle. It's just got to be 180 degrees. Don't worry, people. He was just joking. He's a jokester. All right. So we have 30, 60, 90. Now, that is a special right triangle that you should already know the properties of. If you had my geometry class, you should already know this. This is not a mystery. X radical 3, and a 2x. Now, what does x represent in this equation? X represents the shortest side. We'll call it the old short leg. Bless you. All right. So I'm going to go ahead and draw just a 30, 60, 90 triangle right over here, just for fun. All right. So let's call this the 30, 60, 90. There's the 90. Let's call this the 60. Wait, that's not the 60-degree angle. That's the 30-degree angle. This is the 60-degree angle. So, there we go. So put x here. Put x radical 3 here. And put a 2x right there. So here's what we're going to do. What we're going to do is we're going to look at our picture right here. All right? And ask ourselves, self, where in the world would I put this side of 12 radical 3? Well, which slot? Would that be door number 1, door number 2, or door number 3? Go ahead, sir. You just showed me 2, and then you said 3. It's like you want to be wrong immortally on YouTube. So 12 radical 3 goes across from what angle? You should be able to see it's across from which angle right here? The 60-degree angle. All right? That's what it's across from. All right? So this 60-degree angle opens up to 12 radical 3. So I'm not going to ask you any more questions. Except for I'll ask you. So what would be the shortest side right here? That's 12 radical 3, and that's x radical 3. What do you think goes in? See, that's x radical 3. That's what? 12 radical know that x is equal to 12, I'll plug in a 12. And what's 2 times 12? 24. So where am I going to put the 24 across from the 90 degrees? Ooh, so what does that mean? This side is right here, all the way across. The diameter has to be what? 24 centimeters. So if you would label that 24 centimeters. Now that's important information right there, people. It's important because now I know the length of my diameter. Aha! So now that I know that length, I'm going to highlight it in orange. Where am I going to take that and plug it in? I'm going to plug it in right there. So what is my circumference going to be equal to? 24 times what? Times pi centimeters. That is your answer for the exact circumference in terms of pi. So right, once again, I'm going to write exact circumference. Now, I'm going to explain this to everybody, and I'm going to tell you what I'm going to see. I might see 24 pi centimeters on their paper, but they won't box that in as far as their answer because they still, for some reason, even though that's the exact circumference, they still want to do what? They want to, ooh, that's a nice function right there. Has nothing to do with that. Now, they want to do what? 24, and they want to hit the pi button, and they want to press enter, and they'll put that on the paper. Now, what is this? This is not the exact answer. This would be the approximate answer. Yes, that's the approximate answer. This is exact. That's approximate. Exact. Approximate. All right. So, right there, that's the answer to number 14. The only other problem I'm going to do with you right now is not one that deals with a 30, 60, 90. It deals with a 45, a 90. I wonder what's going to go right up here. Another 45 degrees. Oh, so we have a 45. It's not a very good 45. So what's the other right? Once again, a total failure right there. Try with 4 and a 5. That's bad. All right. So now, what I want you to do on your paper, write down 45 degrees. 45 degrees, 90 degrees. X, 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 radical 2. All right. Now, in a 45, 45, 90 triangle, go ahead and draw it right there. Try to make the legs look relatively equal to each other. All right, that's not too bad. Okay. So in all 45, 45, 90s, you have 2 equal angles right here, which means this leg has to equal this leg. So these legs are the same. They're always going to be the same. The hypotenuse is just whatever that is times the square root of 2. So this is your picture. All right? So what do I want when you're doing these problems? I want you to have this picture for the 30, 60, 90, all right, on your paper, and I want you to have this picture for the 45, 45, 90. So right now, yeah, just put it on your paper so you have it. So you're like, so when you're doing your problems on your own, you're not going, man, I wish I would have written that down because that could be useful right now. What we're going to do up here is we're going to highlight this 45 degree angle. All right. I'm going to highlight that in blue. We're going to highlight this 45 degree angle in blue. Okay. What's wrong? I can't even color. This is just ridiculous. Alright. If I can't. This board is driving me nuts. Alright. There we go. Don't worry, just fast forward. Eventually, I should probably get this colored incorrectly. Just fast forward if you're watching this. About to gouge your eyes out. Stop watching for a second. Okay. Now, this side right here goes across. So these legs right here are equal. So this leg right here is definitely equal to this leg right here. The hypotenuse all right, is the diameter. So what are we trying to find in this one? Once again, we're trying to find the length of this diameter. We're trying to figure out what that is equal to. And that's across from which angle? Hypotenuse. It's across from which angle? Yeah. Otherwise it sounds really weird. The hypotenuse is across from the hypotenuse. That would sound weird. So the hypotenuse is always across from which angle? The 90-degree angle. So we're trying to find the length of this guy right here. That's what we're trying to find. Okay, so do we know this side right here? Yes, we do. What's that length? What is it? No, not 2. Square root of 2. You're right. Square root of, you're right. Square root of 2. Well, if this is the square root of 2, and this is side x, what does this side have to be as well? Yeah, that has to be the square root of 2. So I'm going to write the square root of 2. Now, if you look carefully, x is equal to the square root of 2. X is equal to the square root of 2. What's this x going to be equal to? Square root of 2. So what I want you to do is I want you to write the square root of 2. And what are we multiplying that square root of 2 by? Nope. Yes. We're taking this square root of 2 and we're multiplying it to this square root of 2. Now, by the way, the square root of 2 times the square root of 2 becomes the square root of 4, because 2 times 2 is 4. But wait, what is the square root of 2? What is it? 2! The square root of 4 is 2, which means we found our diameter. Our diameter is 2 centimeters. Our diameter is 2 centimeters. Wait a second. What's the formula that we're using to find the exact circumference? Circumference is equal to pi times the diameter. Well, what is our diameter? Our diameter is 2. So what's our exact answer for this problem? No, that's our approximate answer. What's our exact answer?
2 centimeters square root of pi r.
Okay, here's what I want you to do. I want you to stick a 2. Stick a 2. Stick a 2 right there. Just stick right there. Alright? So that would be pi times what? 2. But we don't call it pi times 2 because we always lead it with the coefficient. We call it 2 times pi. And then you stick a centimeters right there. And that's your exact answer. So the exact answer is not the approximate value that you get. Remember, these are your what? Those are your exact answers in terms of pi. So our answer for this was 2 pi centimeters. You can put that on your paper and know that it's going to be counted 100% correct. Now I'm going to show you guys something that's really cool inside of the circle. Maybe you'll think it's cool, maybe you won't. We'll find out. Alright. Check this out. I'm just going to randomly draw in a diameter. Okay? From that point, going that way, and from this point, going that way. Okay? Would you agree that's the diameter of that circle? So far, so good? Now, Dylan, I'm going to put a random point on the circle. You just tell me where to stop. Right here? Alright. We're stopping right there. Now, here's what I want you to do. Watch what happens. I'm going to go from this point to right there. I'm going to go from this point to right there. You know what kind of triangle I'm making? Nope. Square triangle. Nope. Just any triangle that happens to be a right. You guys got a right angle right there? Huh. I wonder if that works no matter where I put the point. Let's find out. Alright, you choose a different color. Here we go. Tell me where to stop. Right there? Alright, we're stopping right there. Alright, let's check this out. We're going to go from this point, right there, from this point, right there. Check it again. Interesting. What's that another? example of another one. Right triangle. Now, I don't know if you are seeing a pattern here yet, but I bet if I just randomly put another point somewhere here or somewhere up in here, you know what you could do to make a 45, 45, 90? Go right up here, perfectly in the middle, put a point, and then you would have an isosceles right triangle, because from here to here, and from here to here, would also make what kind of triangle? An isosceles right. Now, how do I know that's an isosceles right triangle? Because this leg is equal to this leg. So this one, this is the only case. This is the case where you would have a what? A 45, 45, 90. This is one of the special qualities inside of a circle, guys. If you make a diameter, if you go from this point and you draw any triangle on that circle, they will all be right triangles. They won't be equal to each other, but they'll all be right triangles. No matter where you put one. If I go from here to right there, go from here to right there, what's that going to be? That's another right angle. So you can just make right angle after right angle after right angle after right angle, as long as you start where? Start from one side of your diameter and go to the other side of your diameter. So if you're wondering, like, that's why all of these, I'm going to zoom out, that's why all of these circles right here, guys, all of these circles are dealing with what? Right triangles inside of them. Okay? So right now, I want you guys to find the exact circumference of each circle in terms of pi. So no approximate values. I should not see any, like, lots of decimals. I should just see exact values. Good.